Hi, and welcome to a flipped lesson video for Algebra 2. And the topic will be exponential decay. Writing the functions for an exponential decay, given 2 points, and understanding what it means to have decay. Okay, so let's start with the first part of understanding what exponential decay means. So let's take a substance that you have. And if you talk about it by decreasing by a certain percentage, decreasing a certain amount. So take like a shopping. We go shopping and we see something that we want to buy and it, maybe it costs $20. And we see that it is a 20% off sale. Well, 20% off means we're still paying 80% for the item. And so our growth factor is going to be 0.8 because that's actually what we pay for the item. Okay, so let's take this down and let's write a few things down. So I can have a b of 0.75 to the x, and that's my function. Usually there's a coefficient in front of here. Right now we're going to leave out the coefficient, and let's just say it starts with 1. 0.75 is a value that is between, a b between 0 and 1, means it's a fractional amount. And so if I have 0.75 remaining, then it has decayed 25%. Together, 0.75 and 0.25 make the whole. If I have y equals 0.25 raised to the x, and that would be 1/4. So I could also put that as 1/4 to the x. That means that 25% remains, so it has decayed by 75%. Again, 0.25 plus 0.75 have to together equal 1. So basically what it's saying is the decay factor comes from 1 minus the rate of the decay, and that's going to be raised to the x power. So if the rate of decay, say, it's decreasing by 95% or 0.95, 1 minus 0.95 is 0.05. And so y equaling 0.05 to the x power would be the function that I use, indicating that only 5% remains when it has decayed by a rate of 95%. Okay, so just try to understand that together they always have to equal 1. So anytime you're looking at the b value in the parentheses, the base, the decay factor, understand that it was 1 minus the rate. So whatever that is, and if you have to find out what is the percent that it's going down, you have to figure out what do I add to this in order to get 1, basically. Okay, now with that being said, let's move on to a real problem where you might have to use this. Okay, so penicillin is a medication you take when you're sick. It decays exponentially in the human body. So suppose you receive a 300 milligram dose of penicillin, okay? Now what does that mean? You just received a 300 milligram dose. That means that on day 0, at the start, you had 300 milligrams in your bloodstream. And you're combating strep throat with this penicillin. So we want to know every day what's happening. Well, we know that after 1 day, there's only 180 milligrams of penicillin that are going to remain in your bloodstream. So we want to find out how many milligrams of penicillin are going to be in your bloodstream after day 2 and after day 3 and after day 4, and say even after day 10 from that first initial amount, how much is going to be in your bloodstream. Any medication that a person takes, anything, has some sort of a exponential decay to it. And so things remain in your bloodstream for much longer than you actually think. And it's important to keep your levels up, your titer up at a certain amount. And so when it's figured out how much a person's actually going to take, they take that into consideration, how much it's decreasing each day. Okay, so we're going to write a function in order to understand, and then in order to better predict how much medication is going to be in the bloodstream each day as the day goes on, saying that you only took the one dose. Okay, so first thing we recognize is that the starting place at day 0 is 300. This, as you might have already said, is your y-intercept. And your y-intercept is the value a in the function y equals a times b to the x. Your starting amount is a. So y equals 300 b to the x. Now to write the equation, I need to figure out what b equals. I can't use the same point again, because if I say b to the 0 is 1, 300 equals 300, doesn't tell me what b equals. But luckily I have another point. So 180, I use my y value, y equals 300 times b, I don't know, to the first power, which is my x value. B to the first power is just b, so I divide both sides by 300. Reduce this fraction. 6 divides into both 18 and 30. So 3/5 equals b. 3/5 I can easily convert to 6/10. So 6/10, which is 0.6, if I want to go ahead and use my decimals, means that 60% of the medication remains in the system after the 1 day. That means 40% of the medication has already left the body. Okay, so we're going to set up an XY chart and look at different days gone by and what happens to the blood, the medication in the bloodstream. So we already know 0, 300. We know 1, 800. Let's look at day 2. I'll put in the 1, 800. On day 2, if we now have the function y equals a, the original amount, multiplied by, now you can either use 3/5 and raise that to the x if you prefer using the fraction, or you could use the decimal value, 0.6. I'm going to use the decimal value, 0.6 to the x. So again, this 0.6 represents the decay factor. 0.6 is between 0 and 1, so we know for sure it's decay. 60% remains in the bloodstream, therefore 40% has left. And if I raise that to the second power, 0.6 to the second power, I get a value, and I multiply that by 300, and it comes to 108 milligrams in the bloodstream. On day 3, 0.6 to the third power, multiplied by 300, leaves me with 64.8 milligrams in the bloodstream. And on the 4th day, 0.6 to the 4th power times 300 leaves me with 38.8 milligrams left in the bloodstream. And I could keep going for any day, and you can take this out to the 10th day or the 20th day. On the 10th day, it's going to be a small amount that actually is left, but there is something still left in the bloodstream at that point. And if you actually do that in 0.6 to the 10th power, multiplied by 300, you get 1.8 milligrams, showing that even after 10 days, the penicillin still remains. Okay, so that is all for exponential decay. Again, like the exponential growth video, any 2 points are going to work. you can write the equation using any xy value. If you don't have your y-intercept, you put your larger xy values in first, and then you write a second equation with another xy value, and you divide the two equations in order to solve for b first, then use one of the points and go back and solve for a. So just like in the exponential growth video, the same thing could be applied to the exponential decay. Okay, so that's all for tonight, and I hope you enjoyed the video. Subscribe if you haven't. Bye.